Hello and welcome. My name is Christine Perey, and I'm going to be co-chairing today's webinar on the subject of spatial computing and AR cloud. It's my pleasure to host this on behalf of a consortium of groups. It's a joint webinar, as we'll be telling you a little bit more about in a moment, each of the organizations. Before we start with the more formal introductions, I just want to do a little housekeeping to let you know that all attendees are in listen-only mode, but you have a question console as part of the GoToWebinar control panel, and we do invite you to add your questions in writing using the GoToWebinar tool. Also, we will be having some polls. So we would welcome your participation in those polls, and we'll be discussing your opinions in the context of this, the different topics we'll cover today. This webinar is part of a series of online events that have been organized by the area, the ETSI ISG AR framework, and the XR4ALL project in response to needing to cancel a workshop we had planned in the month of March 2020. So this is our very exciting results of our collaboration. We had a workshop last week, today's webinar on the subject of spatial computing and AR cloud, and a week from today there is a third online event that is on the subject of current trends and future directions for XR. Following that, there is another event on October 7th, which I'm sure you will get more information about through your information channels. So the webinar that we're presently starting focuses on the spatial computing and AR cloud topics, but we're not going to dive into the details of how, from an engineering standpoint, these are achieved. In fact, I think there's a great diversity of different approaches for implementation. And our goal today is more to focus on the drivers and the obstacles. So we'll be speaking about those in different parts of the webinar. And then the last part about the future research and areas that still need a lot of work before we can successfully deploy AR cloud services and experiences. In order to achieve our objectives, we've divided today's webinar into these 4 sections, and I'll be giving a presentation about the drivers, and Jerome Royan, who is also chairing this webinar, will give a presentation about obstacles in his analysis. There will also be some panel discussions, and we will introduce those panels in just a minute. So the next goal is just to make sure you are aware of the 3 organizations who co-organized this webinar. I represent the area. I founded the AR for Enterprise Alliance with the goal of accelerating the growth of the enterprise AR ecosystem. And we do that through these 4 pillars. We provide thought leadership content, including blogs and webinars and other forms of communication content. We help our members and members of the ecosystem to network, share their knowledge, perhaps develop collaborative projects in order to facilitate the adoption of augmented reality. We also know that there is a shortage of people who have skills in enterprise AR, so we promote continuing education and job openings. And finally, we run committees. I chair the Area Research Committee to reduce specific barriers. There are other committees, one on human factors, safety, security, marketing, and requirements. So that's the summary introduction to the area. Muriel, would you like to introduce the ETSI ISG?
Certainly. Thank you, Christine. So my name is Muriel Deschanel. I am Standardization Director at BICOM, a research and technology institute based in France. And I chair an industry specification group within ETSI dedicated to augmented reality. So ETSI is a standards developing organization, one of 3 officially recognized by the European Commission. They develop globally applicable standards for all sectors of industry and society that make use of ICT. You may also know of them through their partnership with 3GPP. They have over 900 members from 65 countries, so there is a chance that your company may be a member of ETSI. So within ETSI, we've set up an industry specification group dedicated to augmented reality. The main objective of the group is to reduce market fragmentation and to encourage a healthy AR ecosystem with a diverse range of solution providers. And for that, we're defining a framework for the interoperability of AR components, systems, and services. And the first step towards greater interoperability for AR was achieved with the publication of a reference architecture for AR solutions that happened in March of this year. You will find more details on the URL given at the bottom of the slide. So if you're interested in advancing interoperability for AR, come and join us. Participation is open also to non-ETSI members, so you're very welcome.
Thank you, Muriel. And our third partner, Oliver Schreer, is here to introduce the XR4ALL project.
Yes, thank you very much, Christine. So my name is Oliver Schreer. I'm working at Fraunhofer Heinrich Hertz Institute in Berlin, and I'm also coordinating the European project XR4ALL. It's a coordination and support action, and it is considered as the first initiative by the European Commission to forge a competitive and sustainable ecosystem dedicated to interactive technologies and extended reality. So this project started 18 months ago in December 2018, and it will last until August next year. And we have quite a challenging mission, which is to establish a pan-European XR community to foster the collaboration. So the aim is to accelerate the growth of European XR technology industry and to support technology transfer and to improve investments by improving investments. And another objective is to develop a research agenda, which is should be used or will be used to formulate the next framework program, Horizon Europe, but also to get in touch with the community and develop current and future needs for successful development of XR technologies. Finally, we have 50% of our budget available as a third-party budget, which is offered to the community via an open call. And there, outstanding research teams can offer project proposals and receive funding up to 50,000 euro. And 2 calls have been already published and they are closed, but there is still a 3rd call open until November 15th, and you can apply for funding via this funding instrument. So I encourage you to become a member of the European XR community and feel free to register as a member on, and you will find all details on our website, XR4ALL.eu. Thank you.
Thank you, Oliver. So as I said, joining me today is Jerome Royan, who is an engineer. He'll introduce himself in more detail in a few minutes. And we do have some panelists who you will be hearing from, and we'd like to welcome them and thank them for all of their support in the preparation of this webinar. Because this topic of spatial computing and AR cloud is widely spoken about, but there's a lot of confusion, we thought it important to introduce some of the key terms. And in our minds, the terms and the concepts that we're going to be speaking about are all nested concepts within a broader context of ubiquitous computing, which of course many people have known about for 20 years or more, at least conceptually. So I'll be defining for you how we will be using these terms today. So as a concept, even though it's relatively well known, ubiquitous computing means that there is the resources of computers and information that are integrated into all aspects of life, and that they are leveraging not only the networks and devices, but the software such as that is embedded in those resources. A lot of use of artificial intelligence and very flexible interaction concepts are included in ubiquitous computing as a domain. Today we'll be talking about spatial computing, which is focusing on 3D volumes, because spatial means that it relates to, occupies, or speaks about the 3D volume and the perception of relationships, perhaps between people and objects or between objects in a space. Sometimes we speak about geospatial, which is a type of spatial data, and specifically when it pertains or is in geographically anchored spaces and the objects and the data associated with those geographically anchored spaces. But with spatial computing as a broad topic, I thought it was helpful to point out to you that the relationships and the interactions that users have with information are shifting. Before spatial computing, our interactions and our relationships are with data on a screen, whether it's a portable screen or a see-through screen or a desktop or laptop screen. And that data is from anywhere and can be about anything close by, in close proximity or far away. But with spatial computing, users are more immersed and engaged in their interacting in 3D and in a time domain with data that pertains to the physical space that user is in or nearby the user. So to show kind of a visual, we think that at the bottom of this figure, this is an abstract figure, not intended to be an engineering diagram or a stack, but at the bottom of the figure is the atoms, the physical world and reality, and they have the atoms have the space has attributes and properties. Oops. And then with spatial computing, users are in that space and can interact with the data that's in the space pertaining to that space. So that's the second concept. AR Cloud is also widely spoken about now for almost 3 years, and it encompasses the creation, management, and use of a 3D machine-readable representation that is persistent, it's being updated, and it can be shared. It's the persistent, dynamic, shareable, machine-readable representation of the physical world. And it has services associated with it, real-time services that offer AR experiences to users. And so this is, I'll be showing you now a few diagrams and figures to explain that. So in this picture, it shows how there's the real world, and it is captured and stored the attributes and properties of that physical world are stored in a digital version. Many different 3D data types and models can be used to capture the real world. Then there is the user in the real world, who is, of course, we all are mobile and dynamic. And on the right-hand side of the figure, you can see that there are perhaps nodes of networks, some of them associated with processing, computational resources, data resources that are near or in proximity to the user. And those resources can store the data, map our physical spaces, and then perform analyses, which we can then query and retrieve spatial data from. So it's a combination of big data, edge, and cloud-based computing and data storage resources. And there's the user who has a position and an orientation, can be derived from a number of different resources, usually from a combination of the user's device and a network. And using the real-time physical world, 3D machine readable world, the user's position and orientation, we can deliver augmented reality. Augmented reality in the top picture on the left shows a geospatial use case, the underground utilities, but it's not. But AR cloud concepts are not limited to outdoor geospatial. Is also locally generated and used spatial maps that can provide someone indoors with some assistance with some dials or making maintenance or other interactions with a machine. And you can see in this illustration on the right that there's IoT sensors that help to show the user the real-time data of the machine. So that summarizes how we see and the components of AR Cloud, the different phases and the results. One of the other key technologies that is less often understood is world understanding. And so this is how we can leverage the 3D capture that we spoke about for AR Cloud, but also more machine learning and artificial intelligence. And core to world understanding is semantics, ontologies about activities and objects that are associated with the features and behaviors of objects and spaces. So imagine you just have an object like a living object like a tree. It's not moving, but well, not moving very far. And we can take a 3D representation of that real world object. And now we have the data from which we can perform machine learning and segment the different parts of this object. And as a result of the segmentation and the analysis, we understand that it is a tree. And then we might also have a bird, and likewise a scan of the bird and identifying the parts of the bird. We can then conclude, the machine will conclude that the bird is flying to the tree. So this is critical to our use in our practical applications of augmented reality in the AR cloud. Now I'm going to share with you a few of the drivers that make this interesting today, and we'll be speaking more about them. My remarks are going to be in three domains: the technology drivers, societal, and business drivers. So the technology drivers, I think we need to remember that without AR cloud and spatial computing, the AR is discontinuous, meaning that it has breaks, it has places where one application stops and another begins. And it's not immersive as it needs to be. So we need to have the ability to move indoor, outdoor, local, or geographically anchored in a continuous way, just like we as humans experience the real world. We need also, there's more and more ability with our devices to use 3D geometries and semantics that make the 3D geometry more intuitive. We need to have, and more people value the persistence of this data so that there's continuity in time, but also the reuse of assets that have been anchored into the real world. So other people may use these identifications or these properties for different applications and objectives. We also think that people are being attracted to the spatial computing and AR cloud because collaboration, whether it's with a remote person or someone who's local, can be richer in 3D when you have a shared spatial dimension. And finally, a technology driver that's very important, and you're probably all thinking about, is that through distributed computing, we can offload the computation and storage requirements for these big data and these artificial intelligence processes. We can offload those to the edge and the cloud, and the user's display as a result of using these resources will be lower cost, lighter weight, and have a longer battery life. So the form factors are indirectly being affected by the ability to adopt more distributed computing. Second set of drivers is around society. We know that people want to take advantage of their technology to enhance, enrich their lives with arts and culture, museums, and so forth. There's also the desire to take advantage of knowledge that is contextual, that is set in the user's environment, and not just when in a classroom or when it's just the time for education, but actually all the time in a continuous way. And some of us need either help with tasks or to get from our current location to another using navigation. That's going to be a very valuable contribution, even above and beyond the location-based services we have today. They'll be richer in three dimension. And then there's the need and the enjoyment and the value to life from collaborating with our friends, our family, our colleagues, and sharing what we see around us. Finally, there's a lot of business drivers. It's my opinion that the greatest use cases in the next few years are enterprise and industrial use cases, because the companies, the businesses, want to optimize their business process. So the first two of these bullets are really about optimization of the business, so to improving quality as well as saving time and resources, but making everything more efficient. But in many industries, and for AR is valuable for customers because it can reduce risk and increase compliance with regulations. So this is all part of business optimization and optimizing human resources, assets, supply chain, work order management, many things like that. The third bullet is around making our employees as valuable as possible, but also to bring more fulfillment to their roles in the workplace. So again, more productivity and operations optimization. Improving the human-machine interface, giving a graphical and a 3D interface to a machine that may not have one already will improve the interaction and the understanding of what's needed. And finally, we will discover many new ways to visualize information in 3D for scientific visualization, for diagnostics and planning, to interact with robots and drones and other machines that are in our environment. So that gives you a good feel for all of the different drivers. This graphic shares in a way how through spatial computing and AR cloud, we can have these thematic layers. The thematic layers are around topics. They contain data, could be static content or live data, services and solutions that pertain to a set of goals, such as navigation in the mobility industry or transportation. Maybe the built environment would have much different data sets and content than for commerce or for entertainment and games or in manufacturing. So these are how different industries or vertical markets can benefit from having the layers below the digital representation of the real world tied to the real world itself and the physical reality. Now, there are many use cases for AR Cloud, and so this table kind of provides an overview that we've prepared for you to understand that there are categories of use cases, such as guidance, learning, but then there are examples. Some of them can be measured as performance improvements in the enterprise. Some of them are consumer facing. So we can say that the end user is someone who is either learning or who is living life outside of the workplace. And we believe that there's many use cases yet to be invented that will enrich these categories as well as create new categories. So with that, I'd like to take this opportunity to ask you to participate in the poll and tell us which use cases, groups of use cases you think are the most important today, or that will be the most important for the first generation. So as you look over those, so I said that there would be, I described 4 categories, and maybe you don't agree and it's not any of those, you don't think it's any of those, and you'd prefer to suggest that there are other use cases we have never seen. So I thank you we're now about 30 seconds into this poll. I'm going to give another 15 seconds, and so appreciate your participating in this, and we'll share the results and discuss them with our panelists. So about 3/4 of you have voted so far. All right. So I'm going to close the poll now. There's 80% of people who have participated. So I hope that you can see on your screen the results of this quick poll. And I'd like to invite our panelists, Jerome, Marco, Vladimir, and Anthony, if you'd like to make any comments or any thoughts about these use cases and how our attendees have spoken. Yes, Vladimir.
Yeah, hello. So we can see quite even distribution with a little lead for guidance, but I think this is because of more, let's say, traditional thinking, because right now, you know, Google AR, and it is about guidance. So it is, I understand it is really difficult to imagine new cases that are not connected to the current ones.
Mm-hmm.
But we see real-time awareness, and well, that's good. That you can imagine a lot of different cases related to this.
Great, thank you. Marco, do you have a comment on?
Yes,
would you like to add anything? Yes.
So first of all, guidance certainly means I'm not going to be out of a job anytime soon. That's good. So from that perspective, I think guidance also needs to be differentiated a little bit between indoor and outdoor. I think we're still a little ways off from indoor guidance to be supported by augmented reality and spatial computing. Outdoor is definitely something that people have looked at in the past. There's still a couple of holy grails that are being developed these days, such as perfectly referenced AR heads-up displays in cars that use eye tracking, for example, to perfectly overlay the data that you see in front of you for safety purposes, of course. So I think it's a pretty good overview of where the market is. I also like the other one, basically the exploration portion of it, the awareness of your surroundings. I think that also has a lot of different use cases that play into this.
Thank you. Anthony, welcome. Anthony.
Hi, this is Anthony. Yeah, I'm Anthony from Universal. I definitely agree with Marco and Vladimir on the guidance part. It's probably going to be, let's say, the starting point for many applications, but I'm very big on the collaboration and sharing of the things. You could call it maybe virtual graffiti or leaving your mark on the spaces and sharing those spaces at the same time or at different times. So that is going to be big.
And I would add that I am more than sure that right now we just cannot envision new directions and new possibilities that AR Cloud will give us. To my understanding, AR Cloud is something similar to the infrastructure, to the road infrastructure in the city. So you first build the road, and then you have a lot of different businesses you cannot even imagine before they start appearing. So I believe the same will be with the AR Cloud. So first we build infrastructure, and then a lot of new businesses will be there. New
I remember when a story that was told about people putting in roads more than 100 years ago, and the customers, the audience said, "But why are you putting roads? My horse can go anywhere. I don't need a road." So as you say, once you have the infrastructure, you invent many new things to go along with it. Are you, Vladimir, working specifically on use cases having to do with, of course, the title of your company is Augmented City, so urban development, urban use cases, but are you working on navigation specifically or other use cases?
Actually, we work less on navigation and more on other things. So definitely we offer both indoors and outdoors navigation, but primarily we focus on the AR Cloud as it is and correct and very precise geopose. So we try to do exactly this, to give the possibility for new businesses to appear, just giving them a great tool.
Thank you. Jerome, did you want to add anything about the use cases or the drivers that we discussed?
Yes, there is no real surprise concerning the pole. Of course, guidance is well known, but just to mention that it could have use cases both in B2B and B2C. B2C, of course, we are thinking about Google Maps, but when we are speaking about B2B, we are thinking about maintenance, for example, guidance for assembly, for logistics. So, of course, there is a lot of expectation in this domain when we are speaking about AR, or more generally, on more specifically about AR Cloud. It's the same for real-time awareness. Of course, there is many use cases, for example, to improve the safety of operators in a B2B environment, such as in construction site, or, for example, in the factory, to have some awareness display on your AR device. And of course, for B2C, we are thinking about shopping, retailing, on all these things. On why not also about a social network in AR, where you will have some awareness about people you know that are close to you. So there is many use cases in this in guidance and real-time awareness. But what is interesting also is other new 12% and that typically says that we have no idea about the use cases that will be created with this kind of technology, exactly as what happened with the smartphone. At the beginning, we had very few applications, and finally, many kind of use cases have been created thanks to this technology, and it will be the same for AR. So, what will be the use cases of AR in the future? We really don't know. On everything will have to be created.
Indeed, it's the good news and the bad news, but it's a very exciting time. And I want to also point out for our attendees that there's a diverse ecosystem that Immersal and Augmented City are young companies, small companies, focused very much in this space. But there's also HERE Technologies, thank you, Marco, for joining us as well, to represent large companies that publish data and offer services to many, many different consortia and use cases. And thank you, Jerome, for co-chairing this webinar with me. Can you tell us a little bit about BCOM and the role that you have there?
Yes, typically BCOM is involved mainly in standardization and also in open source to work on, I would say, spatial computing tools to create this map to be able to localize yourself. So yes, in this domain, and we are looking for use cases in different domains such as industry, or also the domain of health or surgery, or all these applications that are very that are expecting a lot of this kind of technology.
A need for these technologies. Well, so our panelists coming from industry, from startups or large industries, can you tell us a little bit about your business models? Because that was not something I covered in the drivers. Making money from spatial computing and AR cloud today, still a bit of a mystery. Can you explain to us how you approach it?
Hi, this is Antoni Westerinen from Immersal. So our business model is basically to charge on capacity basis on how many maps you create, these localizing maps, and then how many you share, or if you do the relocalization on the server, then how many server AP localization calls you make. So it's quite simple business model for us.
Mm-hmm. So there's not an advertising strategy in there today yet.
We were actually operating on a revenue share model when we started the company, and we were basically augmenting the exhibition centers. But we have exited that business, or it's only one vertical where we have some suppliers, developers working on that, and we have basically entered the horizontal technology business and try to be vertical agnostic.
Thank you. Thank you for explaining that. Marco, how does HERE Technologies view AR cloud and spatial computing? Is this something you can make money off today, and how?
Certainly. So HERE Technologies is actually a B2B company, a large enterprise, as you mentioned, that is very much focused on location data. So we have the HERE platform where we do publish and license out content, location content. So this is something that we're definitely in the business of, particularly in the context of location data, of guidance, both automotive, but also transport and logistics, traffic, and of course, situational awareness. And this kind of information, particularly in the context of the geospatial aspect of it, is something that is definitely at the forefront of our spatial computing initiative, I would say.
Mm-hmm.
Where particularly in, for example, the IVI use cases, there's an SDK that we call LifeSense for hazard warnings and situational awareness in cars. This kind of information is something that provides value to drivers, but also to integrators in automotive use cases.
Mm-hmm. Great. Vladimir, how is Augmented City monetizing the technology that you have?
Actually, our model is very similar to that one of Immersal. We also offer our own SDK, and while it is free to use, but if you have big enough user base, then you pay per localization, which localization costs some very small amount of money. Also, we have some tricks. For example, if you have how much do you pay actually depends on who owns the data, who mapped that part of the world where you localize. So if you mapped your city by yourself, then you are free to use the applications, the technology in that area. But if someone else wants to localize there, he pays. And also we share the profit with those who mapped the location.
I understand. Yeah, the capture of the physical world is critical to getting the pump started, to getting the data sufficient and from many different sources. And we'll be hearing more about the challenges of capturing and mapping the real world in just a little while. So we're wrapping up the session about drivers. Are there any other comments or anything we should touch on before we move to the obstacles? How would we like to? Are there drivers that perhaps I neglected, or perhaps drivers that you think are most important? Jerome, what in your mind is the most important of the drivers for this?
Yes, that's a really difficult question. Clearly,
because you're going to be talking
clearly,
about
yes.
obstacles.
Typically, this kind of technology has to provide a benefit, a return on investment, at least for B2B verticals. So yes, the driver will be for sure, I would say, the money. So if you have some benefits of using this kind of technology, for sure the adoption will come. So I will say that most of the time, the driver will be the money, return on investment.
The business drivers, business process optimization, productivity, making money or saving money.
Exactly.
Mm-hmm, mm-hmm. Do you, well, I think we should, it looks like some other people want to answer. Yes, Vladimir, tell us what you think.
I would definitely count safety as one of the strongest drivers as well. If it can enhance safety, particularly of workers and other situationally aware personnel, that is a strong driver as well.
Risk reduction, risk to people, risk to equipment and assets.
Indeed.
Vladimir.
Yes, and if you accept one very cynical answer, then one of the main drivers these days could be the necessity to explain why do we need 5G, 6G network, etc., etc. Yeah, because, well, what we offer, what AR Cloud can offer is actually a lot more content online, and that's where 5G networks will have a significant advantage over existing networks.
Right. Distributed computing, that's going to cost something. You don't get distributed computing for free. All right. Well, this is when we planned to end our discussion of the drivers of spatial computing in AR Cloud. And I'd now like to make Jerome the presenter so that he can take us through some of the obstacles that an analysis of those obstacles. Jerome, I can see your slides. It looks perfect. Thank you.
Thank you, Christine, for the introduction. So yes, my name is Jerome Royan. I'm a research engineer in the research institute called BICOM in France. I am senior scientist and also principal architect, really focusing on XR technology, on more especially on IR cloud now. So yes, I will discuss about the obstacles related to spatial computing on IR cloud. So just before, we have to clearly understand how this kind of technology will work in a close or very close feature on how we'll be able to map the world together. Typically, we'll have some user that will experience AR in the real world with, for example, a tablet on very good connectivity, of course, as mentioned before. What will happen is that when the user will experience AR, he will start to map the world with its system. We can imagine to have other user experiencing also AR with another kind of device, and it will also map the world. Typically, it's called a SLAM, and you are doing a mapping of the world when you are experiencing AR. And all this data will be uploaded on the cloud and will be merged together to start creating a first level of a map of the world, representation of the world. And this map can be used by other users to provide them some what we call localization or relocalization. So typically, if we want to align or provide some 3D illustration of the virtual content with the real world, we need to localize the devices in a 6 degrees of freedom. As this new user will move, he will discover the part of the world and will complete, correct, and update the map shared by all users. You can imagine that here we have just 3 users, but when we have millions of users, typically we can imagine to have a global AR clouds and plural, because we have different AR cloud provider for sure. So this is typically what will be, I would say, a close feature when we are thinking about IR cloud. So, of course, one of the main obstacles is related to the data management. For AR, first we start at a room scale with typically your glasses or your tablet when you are experiencing AR. Now we try to move to the building scale, so larger scale with bigger map, and why not to the city scale, but generally it's a part of a big city. And we have very few examples of global scales, but they are not really workable today. So it's just mainly using a GPS or this kind of technology for localization. So yes, data storage will be a huge issue, and it will require the efficient 3D map compression schema for sure to have capacity of this map on the different server. When we are thinking about the processing for a single user, so it's okay, but when we are thinking about millions of users, it will be quite consuming in terms of energy, and we'll have a huge amount of data to process on the cloud. I'm thinking about tracking, for example, mapping of the world, the map analysis with machine learning algorithm, and also the rendering to the user. So one of the questions is related to the ecological footprint of this kind of technology. On one side, it will offer a lot of benefits to improve I would say to many services and many purposes to have a better life on why not to solve some ecological problems. But on the other side, of course, this technology will be will consume a lot of energy. So I don't know where the balance will shift when we're speaking about ecological footprints of this kind of technologies. A second issue is data privacy and confidentiality, and also a question of sovereignty when we are using a different kind of technology for IR cloud. On here, one of the solutions will be to encrypt the data produced by these AR devices, and also to encrypt the 3D map. And that's a new field of research typically in this domain to really ensure privacy for concerning the data. But we will come back on this in the next slide. Another thing is discovery, because we'll have a lot of augmentation of digital content everywhere put in the real world. the issue will be to clearly to display the right information at the right place and at the right moment. So for that, we'll have to understand typically the environment of the user, its activity, on what he really wants to display at a specific moment. And to be able to choose the right content, that's a very challenging topic. There is also some obstacle related to computer vision, and more precisely to the visual relocalization. So what is relocalization? It's typically the task to initialize the augmented reality system. When your device is starting, you just capture first images, and you have to understand where you are with a lot of accuracy, so to understand the position and orientation of your device. Of course, you have the GPS, but it's not accurate enough. So we move to the visual computing, and we are using visual computing to estimate the pose, position, or rotation of the device. So what is done is that the system compares the images captured by the device with what you know about the real world, so typically a map that have been previously built. And the problem is that the map has been built a few hours, few days, or months earlier. And of course, the world is not the same because the world is dynamic and everything is changing. So the remaining challenges in this domain are to provide accurate positioning. One difficult aspect is the lighting condition. Typically, you construct a map with a sunny weather, and you want to provide some relocalization during the night. Of course, everything has changed. You are not able to match what you visualize according to the maps that have been reconstructed previously. You will have a lot of dynamic objects with pedestrians and cars that doesn't make sense typically in a map, and that are not built available in the map, and you observe in real time. You have also some movable and non-rigid objects because the world is not static and objects are moving. So typically you will visualize an environment, but the map does not include the fact that objects have moved. There is also some textureless environment, and when you are visualizing a white wall, how can you provide some relocalization? That's the case typically in indoor environment. And one thing that is really tricky is reflective surfaces. So a computer vision system does not understand the mirror. It doesn't understand that it's a reflective surface is a thing that there is a real world behind the surface. And that's a very tricky challenge. And when you have a look to the kind of building you have, both in the streets, the facade of building with a lot of reflective surfaces, but also indoor where you have a lot of glasses, that's a really tricky challenge. Now let's speak about the different technical stages to build and to share these maps, this representation, this twin of the real world, digital twin of the real world. The path is the one-to-one stage. Typically, one user captures the world and will send capture this 3D map to another user to be able to experience AR in collaboration in the same space. Now we are much more on a one-to-many. So first user captures the world, creates a 3D map, will put it on the cloud, and other user will be able to download this map to relocalize themselves, and they will be able to experience AR in collaboration. What is emerging and what is really interesting is the crowd mapping. Crowd mapping is the same thing, except that the other users are able to update the map according to the observation of the AR device. And so it will correct the map, detect that objects have changed in the real space, and it will be able to upload this update and share it with other users. But it takes time, and typically the GRAL is a real-time update, so that is for the future. But to be able to update this map in few milliseconds will provide so valuable information, because you will have 3D information about what's happened in the real environment, and it will be dynamic, and it will provide a lot of information about the dynamicity of the world and what are the activities in the world. So this is so valuable information for sure. Concerning interoperability, of course, there is an issue at the ecosystem level. No interoperability, it means that you will have some lock-in situations that does not favor small players. there is a lack of commonly supported standards. Standards are existing in different kind of organization because a non-moderated framework is quite huge and need a lot of standards, API, because it involves a lot of technologies. So when we have a look to different standardization organizations, they already provide some standard, but there is always some lack for specific parts, such as typically the map that are built. There is no real standard on that. For a user, typically on much more for B2B verticals, we want to swap technology. So we don't want to have high dependency to a single technology provider, because typically you want in a factory, for example, for an enterprise, use whether an AirKit, an AirCore, an HoloLens, and other. And depending of the use case, you will choose one of the technology. And perhaps that if there is a new feature in another provided by another technology, you want to swap from one technology to another one. And essentially, there is no solution that meets all use case requirements. For specific use cases, some technology are better than other. And so today, no solution meets all use case requirements. Sometimes you need specific technology because you are in a specific condition with lighting conditions that are a lot of variables, because you are outdoor, in indoor, or in specific environments such as a construction site. All technology are not working for all use cases. If we focus on 3D map, what is interesting is that AR is not the only domains that are creating some map. Robotics also, autonomous vehicles also. So can we imagine to have some kind of interoperability between different domains that could be great? Typically that the map that are built with autonomous vehicles can be used by AR system when we are navigating outdoor. And last thing is the level of 3D map interoperability. There is, for example, the localization service provider that will only provide the localization of the device based on this map, but they will keep the proprietary of the map, and you will not have access to the map. You have other kind of providers that provide 3D map services. That's typically the case of the panelists that are there today, where you will be able to access a map and so to analyze them and to get a lot of information from this map. And the last level is typically a unified open map that's perhaps utopic, but to have this map that is shared by all domains and that is open and unified, that could be great. Of course, for that, I'm thinking to the web, and the web technology was quite open. Why not for IR Cloud also? Adoption, concerning adoption, of course, we have to find a good form factor. So the AR devices have to be light, with low power consumption, and should have a nice form factor at low cost. So if you want to do that, of course, you will have to move computation into the cloud. So that's typically the promise of 5G, to provide typically high bandwidth and extra low latency networks that are required by AR, because AR requires a very, very low latency in terms of if we want to provide interaction and a good experience for user. Another question that is open is, can we imagine that everything will be put on the glasses, or typically glasses will be a smartphone peripheral? I have no idea. I think that we'll find a different kind of solution in the future. Usability, it should be easy to use, and the interaction techniques have to be adapted to the AR paradigm, of course. And one point that is really important is the comfort of the user, and more especially the view comfort. So typically we'll have to adapt the lenses to the eyesight, because every user has different eyesight characteristics, so we'll have to adapt the lenses. Finally, concerning the social adoption, we have to avoid the whole effect. You will replace the star by the letter you want, but typically it was a fail from Google, because people were not ready to have user with a camera in the glasses capturing you on the world. And so we'll have to take care about first personalizing the design and providing some discrete technology on that's all. Concerning the other question related to adoption, of course, user and enterprise must balance benefits, constraints, and risk. you will have an adoption only if benefits are greater than the constraints for user. Just an example today. Most of people are using Waze or using Google Maps, and they are ready to share their position. So it was an issue for privacy, but in exchange, they receive a service. They got some information about the traffic, and that's a real benefit for the user. So you are ready to share your information. Again, if you have very nice services and benefits for user, people will adopt even if you have a privacy issue. Augmented reality will no longer be a gimmick. Today we're speaking about Pokemon Go, but for sure it will be a very nice tools both for consumer market and also for B2B verticals. And stop to look for a killer application. Everybody is looking for a killer application. We have to think about a killer platform. The question I ask is, what was the killer app of the first iPhone? There was no killer app. It was a killer platform where many services have been developed, and it will be the same thing when we are speaking about AR and AR cloud. And as the solution have to work everywhere at any time on many devices, we will need an AR cloud, so to be able to store a huge map of the real world on the cloud and to update it. And for that, we will need 5G and edge cloud technologies. Concerning privacy principles, as mentioned, the information that are capturing by AR cloud on AR devices is really valuable and most of the time personal. You have to think that it's a permanent 3D data stream of the environment and activities of AR users. So you see typically on the left this 3D map of the world that can be updated in real time. And of course, you will train some model based on machine learning to learn a lot about this 3D representation of the map of the world, such as human recognition, human pose, activity analysis, object recognition, object pose, and much more. This is a scene understanding part. So yes, I have displayed this big brother picture. So take care. I don't say that it's a very bad technology. No, I'm not saying that. I just say that we have to be aware about what can be done with the data captured by this kind of technology. To conclude, what are the obstacles related to privacy? First, there is a dilemma for some of the enterprise. They have to decide between a sovereign AR cloud solution or an efficient technology that provide better competitivity. And that's quite difficult because for specific companies, they are not able to have access to a sovereign AR cloud solution. For B2C market, as said previously, if there is a real benefit and if the technology becomes trendy, most of them will use the technology for sure. And concerning private data management, who will have the proprietary of the data captured by the devices on where the data will be hosted? It will be on your devices or on your set-top box, or it will be managed by a sovereign players or by a big player such as a social network. That's an open question. But what we have to understand is that for B2B, if there is no trust in this data management, we'll have no AR cloud or no AR. So finally, this privacy government institutions need to consider new regulation concerning the privacy of AR cloud technology for sure, and they have to prepare that very soon. If you are interested in the topic, just have a look to the XR4ALL privacy framework. There is a URL just on this slide.
Thank you, Jerome. Thank you, that's great. Covered a lot of territory very quickly, raised many important issues. And now we're going to spend 10 minutes or so with our panelists. Can I ask you to flip to the next slide, please? So I think from my point of view, the area that I'm working on the most is standards for interoperability to address some of those issues that you mentioned at the beginning. And I know that you are also actively working in those. There's other approaches to developing interoperability than standards. I'm thinking of test beds. Can I ask Anthony to tell us a little bit about the OSCP testbed in Helsinki, and Vladimir tell us about the Bari testbed and how those work for interoperability.
This is something. So we are, or we have already mapped about 1 square kilometer, so a million square meters in Helsinki, and basically set that up as the initial test bed for the relocalization and the spatial discovery services. That's ongoing, and we are setting it up as we speak. But the initial mapping has been done, and the intention is that we expand the area and also provide the new maps as the locations have changed. And then I don't think Jerome mentioned that one of the challenges of the machine vision technology is the relocalization in different lighting conditions, as an example. So in practice, you need to create and map the outdoor spaces at least 2, probably 3 times to have the maps available for different lighting conditions, and that's what we are doing right now.
Especially it will be dark in Helsinki. So you need to have it be, it's not just night. It's
we are entering the dark ages now.
Yeah. Vladimir, you're in Bari in Italy. There's plenty of sun there.
Yes, but you know, a lot of sun also can cause problems to visual-based solutions. So sun blinds everything sometimes. Well, but about our test bed. So our test bed in Bari is the first OCP test bed and the biggest one. So currently it covers the whole city, outdoors, and a number of indoors locations as well. So the total area of testbed is about 100 square kilometers. Plus, we are adding new, other cities. So we added several smaller cities that are close to Bari, and we have locations also in Amsterdam, in Barcelona, in Seattle, Moscow.
Can you tell me how does the testbed address the obstacle of interoperability? How will you collaborate with other companies to test interoperability?
Yes, thanks. It's a very good question. Actually, we are working closely with other ORC members, and our goal is to make the main service, so-called spatial discovery service, agnostic of the localization providers. So our goal is to provide geopose and provide information on geospatial objects, regardless of what provider you use. For example, here in Bari, obviously, we are the main provider here, Augmented City, but we used Immersive SDK to map some part of the city as well, just to test how the concept works. And we are planning a series of seminars for developers here locally. Also, we plan a big hackathon where we believe to have a number of international teams as well participate in it. So quite soon, soon, a lot of technical guys will be able to test their solutions and how interoperability works.
Okay, thank you. Jerome, did you want to manage the discussion, or would you like me to continue asking panelists questions? you're muted. So I'll ask Marco. Marco, here has been around in the. Okay, go ahead, Jerome.
Please, let's continue. Sorry, I was just saying that you are doing it very well, so please, you are welcome to continue. But just one point concerning the testbed. Yes, typically we need to have a lot of players in the loop. We are thinking about 5G providers, edge cloud providers, people who are providing the technologies, such as the panelists we have here, and also end users that are thinking about services, and sometimes we need to have also CT involved in this testbed. So yes, these testbeds are really crucial to really start developing this kind of technology and show that it's wonderful and it provides a lot of services. That's all.
It's in fact good that you pointed that out to keep us on that topic one more minute, because I was recalling that a few weeks ago, 3 weeks ago, I think, Niantic announced a consortium for spatial computing and AR cloud with 5 or 6 network operators in different regions. So that's one initiative that's already looking at how to use the 5G services in different cities from different providers. That's in parallel and much better funded, I'm sure. But sometimes the amount of money putting in is not the most important criteria. I was going to ask Marco if you would talk a little bit about privacy and data privacy, and how here, who has been doing these kinds of services and data, at least location-based services, for a very long time, what are the procedures or the policies that you have in place today for protecting data privacy in your services?
Yeah, I mean, I can't go into too much details naturally, but I would say a couple of particularly locally addressed regulations have to be taken into account. I mean, in Europe, it's pretty straightforward with GDPR. There are similar restrictions in other countries that vary, of course, but generally speaking, we do provide a platform that allows you to upload data as well, and of course consume data and license data and so forth. And it certainly has to incorporate a licensing system and an authorization system that does provide you with access rights that are limited and can be controlled by both sides, and also allow it to download the data that you're authorized and you're licensed to, for example. So this is something that has to be taken into account naturally. This is also something that's incredibly important for our partners, particularly in the automotive sector, where, as you mentioned before, now with cars that are being connected and streaming data in some cases and a multitude of sensors, these kind of pieces of data need to be protected and need to be, in some cases, anonymized so that they can't be traced back to individuals. I mean, especially for organizations of our size, this is absolutely crucial. So, and I mean, with that being said, recently, and you mentioned that already in your slides as well, the XRSI issued a framework. The XR Safety Initiative issued a framework document that outlines, I think it was 120 control points, how to ensure data safety, especially in the XR space. And I think that's a key component, a key initiative that definitely needs to be at the forefront of this kind of information being distributed, especially in an AR cloud.
Right. Thank you, gentlemen. I think actually talking about the obstacles will transition very, very nicely into the next part of our discussion, our webinar today. Jerome, would you mind advancing the next slide? We're going to spend about 10 minutes talking about future trends and research directions, just taking a moment or two, each of us, to describe what we think to be some of the most urgent, important topics to to be studied in a research capacity to overcome the obstacles in question. And I think I'd like to start by asking Anthony, because one of the things that you, I believe, are working on is how to keep the data fresh. Could you talk to us about that in terms of the what's the research on that topic, and how do you approach it?
Yes, that's an excellent question, and I think you mentioned earlier that some companies are doing these efforts with well-funded backgrounds. I don't think that funding is the issue here. Okay, it is that we get the people, the users, people on the street motivated to share their data, and maybe 2 steps back there, that you cannot map the environment for AR and AR cloud using satellites. You have to be on the street level for the relocalization. So the models, the AR cloud has to be made from the street level. And you can't drive the Google vehicles into shopping centers and walking streets. You have to rely on the people. And Immersal and my view is that you can call it the Wikipedia model or whatever, so that the users, as Jerome pointed out earlier, see that the value of providing the data is greater than the privacy that they basically give up. And as an example, we have already taken the first steps at Immersal to enable that on our developer portal. Okay, it sounds technical, but whoever makes the first maps of the surroundings can decide themselves if they want to share them, if they want to make the maps public. And then if they do make the tick in the box, then everyone can basically use and benefit from it. And that's where we think this needs to go. Of course, as we have to live also on this, so there has to be some money changing hands somewhere, and our model is that when you are using the data for relocalization, we take a little share of that, but sharing the data doesn't cost anything and shouldn't cost anything for anyone.
Thank you. That's really good, because I think research has to happen both at an engineering level as well as a market level, in collaboration with users. Marco, could I ask you to speak for a few minutes about how you see the greatest research needs? What do you see to be the most urgent topics?
Certainly. So first of all, I mean, if you look at immersive experiences as these 3 pillars of positioning and rendering, of AR cloud, so platform and storage, and of course of a machine readable contextual map that makes up the digital twin, you're looking at a multitude of requirements that are frankly too much for any one provider to handle. Particularly in literally all use cases and solutions,
and globally around the world.
Globally, right? On top of that, exactly. Which is hard enough to do even from a mapping perspective. So I think the interoperability portion of it is absolutely key, because you're not going to get around interoperating with other solutions. And I do see a big danger in relying on these walled gardens, these silos that some of the bigger players are putting up right now, that kind of limit you into using one ecosystem. So I do believe making sure that even those, let's call them walled gardens, of course, are interoperable in some form or another and follow standards, particularly open source standards, is incredibly important.
Mm-hmm.
And also from a commercial perspective, bigger players need to understand, and most of them actually have, fortunately, that the open source community is an untapped market. I mean, there's a lot of developers out there who are not building commercial solutions, or who may develop commercial solutions sometime in the future. And you're not tapping into their expertise, into their market and everything, if you're leaving them out in the cold because you're making your licenses too expensive, too uninteroperable, so to speak. So I think it's incredibly important that even the big players and the open source community, a good example being the OpenAR Cloud, with their open spatial computing platform, and of course the OGC, the Open Geospatial Consortium, with the GeoPose initiative, to work with each other and make sure that all of these technologies work together and provide a multitude of different use cases and solutions for practically any market.
Right, and include a lot of innovation that can happen in small companies that's less easy to do in a big company. Could I ask, Vladimir, could you tell us a few points about what you are concerned about and what you think is the next research topic, or where you would like to see more effort put?
Mm-hmm. Yeah, thanks. So first of all, I agree with Marco that interoperability is very important here. And for example, if we talk about the list of obstacles that were shown before, I think that majority of, let's say, low-level technical things are already resolved, like working with the different weather conditions, or working with different lighting conditions. So that's not that difficult. I believe the biggest need for research is in the field of, let's say, real-time communication, where we deal not with the static scenes, but with something constantly moving. Because okay, so for us, so we map the city, and we are totally fine with localizing, well, everywhere and in any weather conditions. But we cannot, for example, tell that this bus or this car is exactly that thing we are looking at. So when we start talking,
dynamic data types or dynamic objects are very challenging.
Yeah, dynamic objects are challenging, and currently there is no even good known approach how to start with this. So probably what is called reality modeling language is the thing to deal with this. When we try not to just algorithmically localize our position, but shift to the understanding of the scene.
Right, so, the world understanding.
Yeah, world understanding is the main topic for research, I think.
So I have, I'd like to nominate two topics for high research focus in the future. One is exactly what you said, a reality modeling language, but I'd like to make sure, to the extent possible, we adapt existing models and existing languages that use semantics and ontology systems that have already been defined for factories or for different classes of objects, urban objects. I know there's a lot in CityGML, there's ontologies there for buildings and fire hydrants and balconies and all these things. So there already are many standards and semantic tools that can be used. But we need those to automatically increase the understanding of our spatial maps without reinventing the wheel. We need to provide these big data sets that we have, or you are developing, to those systems, so we don't have to start from scratch. The second topic that I hope will attract some people is the use of user context to discover content for AR experiences. So the ability to use some profile of the user that they have private, but it includes their state of mind, their physical location, orientation of course, what time of day it is, if they're going to the theater, or if they're going to work. They're going to the user context is so important to defining what the discovery of content will be. With this, I'd like to start another poll and ask our attendees, the participants of this webinar, if you have any opinions about the topics you feel should receive the greatest research in the near future. So we have here real-time and accurate world capture and mapping. That was mentioned several times. Semantic segmentation and understanding of the world. That's included what I was speaking about and what Vladimir was speaking about. Of course, there's still a lot of work to do in natural feature recognition and tracking. There's been some discussion, not very much, about improving hardware, which is interesting because usually in these webinars or in discussions with professionals in this field, people complain about the hardware. And then there's sort of distributed computing, off device, on device, and all the different management and storage and privacy concerns. Do you think we should continue to have more work on that, or sort of? So we have about half of the attendees have participated so far in the poll. I'll give you another 15 seconds. So these are topics that we have spoken about, and I think are all important. It's just prioritization. How on earth can we prioritize? Okay, this almost 80% have participated. So now I'd like to share the results of the poll. Can you see the results? Jerome, can you tell me if they're appearing on your screen?
Not really. I will stop to share and I will give you the hand to be sure that everything is working well. But on my screen, I do not see.
Vladimir or Muriel, do you see the?
Yeah, I wanted to confirm that we can see it. We can see the results.
Thank you. Great. Let's see. Okay. I need to catch up with where Jerome was. We just have 3 minutes left, so very little time to really to discuss these results, but it's interesting that many people agreed with Anthony that real-time and accurate, well, we all think that real-world capture and mapping is important, so that's a very interesting result. I'd like to do one more poll before we close, and let me go ahead and say like this. I'm going to share my screen so you see that while I'm okay. Let's see. Why am I not seeing my screen? No. Well, I'm going to go ahead and start the poll, and then I'll figure out the next. So this is one about time frames. When do people think that spatial computing and AR cloud will be useful for you? Is it soon, or is it further out? What do you think is realistic? There's some simple things that we can do right away, and then of course more sophisticated things. This is not a fair question. It's a bit of a trick question. But we're very interested in hearing how people view this in terms of the time frame. And it looks like so far we've got 60% people have voted, and it's pretty clear that there's a lot of optimism. So 70–80% of the people have voted, and I'm going to close the poll in 5 seconds. So if you haven't voted yet, please do. So I'm going to close the poll, and I'm going to share the results. So it's hope you can see that many of you got gosh, 67% think it's in the next year, 2 years, very soon. So it's exciting to see that people are really eager for this and they see it in the short term. So I hope many of you will be highly successful in achieving your goals and making spatial computing and AR cloud services available to all of your customers and partners in the future. And with that, it's been a great webinar, very, very fast-paced, covered a lot of material. I want to thank the panelists and Jerome as my co-chair. Thank you all for making this webinar possible, and there will be a recording. The archive will be available from the area YouTube channel. You will receive an email with a link to that very soon. Thank you, everybody. Thank you.
Thank you, Christine, for chairing the session on this webinar. Bye.
Thanks for the invitation.
Thank you.
Cheers.
Bye-bye.